This is a tutorial to complement our PowerPoints on measures of dispersion and calculating t. In those PowerPoints, I looked at the height in centimeters of 4-year-old red oaks, and I compared them to the heights in centimeters of 2-year-old red oaks. And we found the variance of both, and we found t for both. So I'm just doing that again a little bit slower for the people who need that extra help. So just like most things, I'm going to start with a null hypothesis. HO. HO is our null hypothesis. It always is. There is no difference. If you are in my class and you struggle with math, that will always get you at least half a mark. There is no difference. There is no difference in what? In the heights of 4-year-old red oak trees and 2-year-old red oak trees. Now, the first things we need to find the size of our sample. We need to find the mean, and we need to find variance for both of our populations. That's the data we need to find t eventually. So how many numbers? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Excellent. To find the mean, I have to add them up and then divide by 8. When I do that, I find out it's 85. Over here, we have 1, 2, 3, 4, 5, 6, 7. And then when I add them up and divide by 7, I get 46.71. Now you may have noticed I'm a little bit lackadaisical with my significant figures. I usually round to 2 or 3 decimals depending on how the numbers work out. If I'm dealing with smaller numbers, I might go to 4. I'm not too worried about it. If the answer is 46.71 and you have 46.7, I'll give you the mark. If you have 46.69, I'll probably give you the mark. I'm not super worried about how we round things. So to find variance, you might remember the variance equation is the sum of each point, subtract the mean, and square, and then add them all up. And then we're going to take the sum of the squares and we're going to divide it by the degrees of freedom. So to do that, we need to find what this numerator, the sum of the squares, is. I like to do that in columns. It's easier on my calculator. So I'm going to take each point, so xi is any point. So I'm going to take each point and I'm going to subtract the mean from it. So I'm going to do this with my calculator to show you guys as we go here. So I'm going to take my first point, subtract the mean is 6. I'm going to square that. Equals 36. And then I'm going to take my second point. I'm going to square that. And I'm just going to keep going like this. Don't really need my calculator, but you can see to square it, it just times it by itself. Here we're getting negative numbers. That's okay, because if you take that negative number, so 4, and then I touch this plus minus sign, now it's negative 4 times negative 4. It still equals 16, just like 4 times 4 does. That's why we square them, to get rid of those negative numbers. So negative 5 times negative 5 equals 25. Negative 9 times negative 9 equals 81, just like you'd expect 9 times 9 to. Then we need to add all of those up. We get 203, which is totally different than when we did it before. It was 192 before. Oh, this was 90 last time. Is my mean still 85? I've made a mistake, guys. That's different than what I was expecting. I'm going to do this again. If this number was 90, then this would be 5, and this would be 25. I'm going to try that again. 25 plus 16 plus 16 plus 9 plus 4 plus 16 plus 25 plus 81 is 192. That's the number I'm expecting. 192 divided by 8 minus 1 is 27.43. I copied down my number wrong. It is really easy. When you guys make mistakes on this, it's not usually because you don't understand the math, it's because you've copied a number down or you've typed something into your calculator wrong. I recommend doing your calculator twice and double checking. I'm hoping I've copied these numbers down accurately, but I guess we're about to find out. So, to find the variance over here, it's the same thing. We need to add up, we need to take each point, subtract the mean, square it, and then add them all up and divide by the degrees of freedom. All right, so this one, I forgot to put this over here, 27.43. Okay, so now we're going to do 52. Oh, clear. 52 minus our mean of 46.71 equals 5.29, and I'm going to multiply that by itself. Square it. It's 27.9841. I'm just going to put all the decimals in here for this one. I'm going to do that again. So 51 minus 46.71 equals 4.29 squared. Multiply it by itself. I get 18. 48 minus 46.2, nope, back, 71. 1.29 times 1.29 equals 1.6641, which is the same for this because it's a duplicate point, which is nice, speeds things up. 45 minus 46.71 negative 1.71, so times 1.71 negative, becomes a positive, which is the whole point of why we do squaring. 43 minus 46.71. Negative 3.71. We're going to square that. $13.7641, and then we have 40 minus 46.71. Negative 6 and negative 6.71. It's 45.0241. Now we need to get the sum of the squares, so we need to add all those points up. Plus 13.7641 plus 2.9241 plus 1.6641 plus 1.6641 plus 18.4041. I'm going slow. I'm trying to double check my numbers as I go so I get it right. 27.9841 equals 111 point. I'm going to round that to 43. So now I take my sum of squares and I put it into my formula. The sum of squares divided by the degrees of freedom, which this time is 7 minus 1 because we had 7 points. So 11 divided by 7 minus 1 is 6, and I get 18.57. Excellent. That is the number I was expecting. Fantastico. So these are the numbers that I need going forward to run a t-test. So let's do that next. So t equals our mean from our first population minus the mean from the second population. I'm going to take my degrees of freedom from my first population and multiply that by my variance from my first population. I'm going to add that to the degrees of freedom of my second population times the variance of my second population. I'm going to divide that all by the combined degrees of freedom. I'm going to multiply it by this little thing that I don't know if it has a name, but it's pretty easy math. And I'm making sure that it stays underneath my lines. This has a tendency of floating away if you don't make sure you keep it in every row. So then we just plug in our numbers. Make sure it stays in there. So I'm going to do 85 minus 46.71, and I get 38.29. And then 8 minus 1 is 7. So 7 times 27.43 equals 192.01. And 7 minus 1 is 6. So 6 times 18.57 equals equals 111.42. 8 plus 7 is 15. And 8 plus 7 is 15. We just did that. 8 times 7 is 56. So we're keeping our 38.29 up here. 192 plus 111 is 303.43. 15 minus 2 is 13. 15, oh wait, let's wait till the next one. So keeping our 38.29. Oh, let's move up here, sorry. So 303.43 divided by 13 is 23.34. 15 divided by 56 is 0.2679. Well, that's a hard one to round. T equals, keeping our 38 and our square root, this number times 23.34 equals 6.25. Now we finally have this down to one number. And every calculator is a little bit different. Can I just press square root? Oh, I don't have a square root, so I need to move this on its side. Can I just press the square root symbol? No, it doesn't want to. It wants me to press the square root symbol first. So I've got 6.25, so I'm going to clear, and square root of 6.25 equals 2.5. I'm going to go back to my normal calculator. So I finally got this down to two numbers. Yay! So 38.29 divided by 2.5 equals 15.316. Huzzah! That's our calculated. So we need to take our calculated t equals 15.316. We need to find our critical t. Our critical t is on our critical table of values. So our degrees of freedom is n minus 1. But we have two populations, so we need to add them together, which for us is 8 minus 1 plus 7 minus 1, which equals 13, which you might have noticed is this here. That's our combined degrees of freedom. So we're going to follow down to our 13th row, and our degrees of freedom, oh wait, our critical T is 2.160. Now, in my other video, I showed that this is our critical cutoff line. So if our calculated T is greater than that, it is different. We reject it. It's greater than that critical cutoff line. If it's less than it, it's the same, we accept. So 2 dots for my big number, 1 dot for my little. Our calculated T is much greater than our critical T. Therefore, we reject our HO, which means there is a difference. What is there a difference in? I'm going to write my concluding statement up here because I don't want to start a new page. There is a difference in heights of 4-year-old red oak trees and 2-year-old red oak trees. Yay! And that is how to run the t-test by hand.